Hi.
And what club to Snart come?
Hello.
Hello
Well-
and welcome to Snart Club.
I'm James Bonk,
And I'm Xero.
and today,
We're talking about holes.
you know, the one advantage of getting your information fresh from the Snart Club is that it's delivered to you by people with extra large eyelashes,
Yeah.
so you know you can trust it.
The biggest eyelashes, the biggest holes, the smallest particles. That is what is on the list for today.
Yes. Tell me about holes.
Okay, the biggest holes. Yeah.
I can't wait.
You've heard of the song Supermassive Black Hole.
I have.
Well, they're gonna have to rewrite it.
What?
Because we've just discovered an ultramassive black hole.
Oh, you're kidding.
No.
This is like the Pokemon balls. Like, every time you go and find a more advanced Pokemon, it's like, no, you need the Ultra Ball. You need the Master
It's like Candy
Ball.
Crush levels, like it never ends.
They just keep inventing new shit. Are they going to make, like, a Premium Plus black hole? Is it going to get, like, Supermassive, Ultramassive?
That's already a tier on OnlyFans that you can read.
But is it not a tier of black hole I can reach?
I mean, apparently this one's getting close to the upper limit.
No, one thing I do not believe scientists on is that they're like, guys, we've definitely found the biggest black hole. Like, we haven't checked.
You
but
know that guy was at work, like, it doesn't get bigger than this. So, this black hole is the size of about 30 billion of our sun.
That's...
Quite large. It's much larger than the black hole, which is at the center of the Milky Way.
I always forget that there's a black hole at the center of the Milky Way.
We're going around the hole, baby.
That's like, we're circling the drain hole.
We are! Like, right now we're going around the hole.
That's why it feels so stressful on this earth right now. We're getting closer and closer to the black hole.
Pull me in.
Ready.
Take me.
Consume
Take
me.
me.
Oh my god. Like Florence and the Machine. Pull me under, control me. What did she say in Dreamgirl Evil?
She should write ultramassive black hole. Because I would be streaming.
Yes. And she'd make it hot.
Yeah.
And that's what we really need when we're talking
Yearning
about...
for that hole.
We've all been there.
Yeah, we've all been there.
So, you said it was getting to the upper limit, but I'm struggling to understand that you're like, oh, it's as big as 30 billion suns, but we don't think they can be much bigger. Like, how do we know?
I mean, this is not a very active black hole, and I think that's why...
Is she hibernating? Why is she not active?
She might be. She's just so fucking large. She already ate.
She's clearly losing her motivation. Like, she's achieved everything that she wants to achieve in life.
Yeah.
She's as large as 30 billion suns, and she's finally like,
She's
yeah,
giving
that's
her
enough.
final Broadway
I
performance.
think I'm gonna settle. She's gonna retire. Yeah. So how did we stumble across her if she's just lurking and not being active?
Well, she was a difficult one. Like, if you think about the black vacuum of space, how are you going to see a big black hole? Because the whole thing about black holes is that they suck in all light.
Oh, classic.
And all radiation. So there is nothing we can detect. But the reason we found this black hole, which is the first time that's ever been done, is something called gravitational lensing.
Cracks knuckles. Can you tell me what
I can't
gravitational...
crack my knuckles, but I can tell you what gravitational lensing is.
Wonderful.
So basically, this black hole is between us and another galaxy.
Oh.
And we could see the light coming to us from that galaxy kind of bending.
Oh.
Yeah.
I've heard about this effect. Do
So
we use it to discover other things or to like figure out
We
where stars are
do.
and stuff?
So we actually can use it to see that faraway galaxy in a little bit more detail.
Really?
Because like it kind of magnifies it as it bends around.
Really?
Yeah.
Gravity is so weird
Gravity
and
is
interesting.
crazy.
I love it.
So the light that doesn't get sucked in, like on the outer edges, it just gets bent in, if you can imagine.
And that's like a magnifying glass
And
for
that
us.
is like a magnifying glass.
So this black hole that's the size of what, 30 billion suns?
Yeah.
Is doing us a big favor.
Yeah. It actually
She's
is.
helping
Like,
us see our neighbors.
this is our new telescope, this giant black hole.
I love that that's so organic. Like, it's an organic telescope that's already out there in the world.
Yeah. Like, she's helping us go beyond our limits, you know?
Oh my god, thank you,
Thank you,
ultramassive black hole.
Queen.
Do you think she has a name in the same way stars have names?
She does have a name. And here we have Lab Rat to tell us the name.
I love gravity, personally.
Gravity. The word gravity is not in that song, is it?
It's not, but it would do so well in that song. I mean, I feel...
You still knew what I was singing from
Gravity! Do you know anything about the forces? Do you believe in gravity?
So basically, have you ever thought about how things know that gravity is acting on them?
Like how you feel it?
Or like take two magnets, right? Like let's take electromagnetic
we are always
repulsion.
taking two magnets.
Just take two magnets. But if you put two magnets that are attracted to each other next to each other and they how did they know that the other magnet was there?
Through the electromagnetic force?
Yes. And do you know what particle mediates the electromagnetic force?
No. Electrons? No.
No. Electrons have an electromagnetic field.
Every single one of them?
Yeah, they have a charge.
Wait, there's too much. I'm just coming to terms with the fact that everything is a magnet.
Yes.
Everything is magnetic all the time.
Yes.
Do you think that in some ways, like, keeping me together, it's magnets?
Yes.
Yes! Obviously!
Keeping every atom together is
It's magnets.
the strong and weak electromagnetic force.
What's the difference between the strong and weak electromagnetic force?
So the weak one is the one that we experience regularly.
You're telling me the one that we can, like, interact with in the real world is
That's
the weak
the
one?
weak one.
Oh, the strong one. Honey.
Yeah, honey.
She's strong.
The strong one is only in the nucleus.
Oh! It's so strong
That it
you will
overcomes
create...
the weak one. Like, think about if you have a bunch of magnets that are the same charge, right? And you're trying to push them together and it doesn't want to work.
Yeah.
And then think about protons are all just little bundles of the same charge. How are we cramming a bunch of protons together?
How are we cramming a bunch of protons together? So the strong electromagnetic force is a type of magnetism that is so strong that if I mess with it, I will create an atomic bomb.
You will have, yes, nuclear fission.
Wow. I really didn't respect the power of magnets until
Yeah.
now. I didn't realize how important they were. Is maths? No, I don't want to know.
Just ask.
Is maths science?
Maths is better.
What?
I mean, I feel like we agreed that chemistry is just like relies on physics.
As a physicist, would you say that almost everything relies on physics?
Yeah, but then all of that relies on maths. I prefer maths. I just thought it would be easier to get a job in physics.
Really? Oh, we're so good at clapping.
Hello and welcome back to Snart Club.
Welcome back to Snart Club. We have another segment of Snart News for you. And my Snart News today is about my darling, my idol, my beauty, my girlfriend, my love, my queen.
Ooh.
The Large Hadron Collider! You know I'm never going to shut up
this
about her.
large donut.
I like a lady who's large.
I love a lady who's large and donut shaped and made of metal and other
I love a lady who can, like, spin protons around really fast.
I love a lady who's like kilometers in diameter.
Who is very expensive to build.
Exactly.
Yeah.
An expensive girl.
An expensive girl! My girlfriend, the Large Hadron Collider.
Tell us about that.
So, we met. So, they've been colliding beams of protons.
Uh-huh.
And they've got this new sensor.
I know protons.
You know protons?
I know her.
Prove it.
She's in me.
Now she's in me, always with me. Tiny protons in my body. Hold me closer, tiny proton. So obviously, donut-shaped tunnel. Like, smash those protons into each other as hard as you possibly can. That is what she's great at. That's what she's been doing for years.
Mm-hmm.
But now they've built another special sensor within the Large Hadron Collider that's going to help us detect neutrinos. And for the first time, we've detected high energy neutrinos in the Large Hadron Collider that we like created when we were smashing beams of protons together.
Okay.
I'm using we, like I'm just gonna claim
Yeah,
to be part of the
you were
achievements
there.
of the whole human race.
Your girlfriend.
Yeah, well, she was my girlfriend.
I mean, tell me about it, because I know that neutrinos are famously hard to see.
Yes! So...
If you don't know anything about neutrinos, they're
You should
really
know.
fucking small.
They're really small, they don't interact with ordinary matter very much, and we actually don't know if they really are ordinary matter.
They don't have any charge, so we can't use like magnetic fields to detect them.
Previously, one of the things... Well, there's a couple of things we've been doing to try and detect them. So, like, there's a massive, like, a kilometre cube of ice with lots of, like, sensors pointing down into it to try to detect neutrinos passing through the Earth. There's also this like massive, it looks like a round wizard potion vial full of like, I think it's like 1,000 cubic meters of heavy water, because sometimes the neutrinos will react with the heavy water to produce a special type of radiation. But like, the neutrinos passing through the Earth are like so many, and we're going to detect like 3 of them, because they're ghost particles.
So there's neutrinos passing through us right now.
Right now! They're just like whizzing through you, but they're lurking on the group chat, then you can't feel them, you can't see them.
It's so weird to
They're
me
not
that we're like
interacting.
not that solid, like things are just going through.
Are there holes in you that allow the neutrinos to pass through?
Yep.
There's a lot of space inside you.
There's so much space in there.
Like between...
If we got sucked into a black hole, we would be like
Oh, we would be compact.
compacted into like
We would fit into a little...
a
into a little compact...
million of us.
A million of us.
Yeah.
There's that
Turning it
little
back
matter in
in.
us. That's so wild.
Yeah.
I want to tell you something about high energy neutrinos. They normally come from really far away. Like, we've sometimes detected them like in cosmic rays, or they come from like a solar flare or something. So to actually create them in like a controlled lab environment is like, whoa! And then to be able to detect them, like, whoa! Something that I love about neutrinos is sort of the element of mystery, and how important they could be, and how trans they could be. Trans Day of Visibility, welcome back neutrinos to the show. In the beginning.
Yes. God created the universe and all of its beautiful
Absolutely not! At the start of the universe, there was created ordinary matter and antimatter. And when ordinary matter and antimatter meet, they destroy each other.
That makes sense.
They destroy each other, they become just energy. So for a long time, people thought that there was equal amounts of ordinary matter and antimatter created in the Big Bang. But if that were the case, they should have probably like destroyed each other by now, and there should be
Yeah.
nothing left except pure energy.
Come and get me. Like, where are... I haven't heard the threat.
So, there's actually more ordinary matter than antimatter in the world, and we don't really know why. But the answer could be neutrinos being trans, because we don't know. We don't know if neutrinos are like antimatter or ordinary matter. They're not existing in that binary. And some people even say that a neutrino could be its own antiparticle. So most ordinary matter particles that make us up, they also have an antiparticle. Like everyone has a shadow, every particle has an antiparticle.
Yeah. And an antiparticle is a particle that is exactly identical in all properties, but it has an opposite charge.
Exactly.
So if neutrinos have no charge, what is the opposite of zero?
Yes!
You know?
What is your opposite? This is why they can feel neutrinos.
Like, it's still
They're on their
zero.
level.
I am my own enemy. I am my own antimatter.
Oh my god.
I destroy myself.
Oh my god!
Florence wishes!
We do believe very strongly, Florence and the Machine, if you're listening, I think you should write a song about
I'm talking
neutrinos.
to the machine. Can you get a hold of it?
So, neutrinos. It's very possible that, well, I say very possible, it's one of the current theories, that at the very beginning, in the Big Bang, there were neutrinos, and they began as antimatter and transitioned into matter. And now they are our non-binary queens.
They're our non-binary ghosts that pass through us every day.
Yes! And that's why I love them. Yes, come at me,
Pass
Emmys.
through. one of those people in church that's like, I'm feeling the spirit.
When you're feeling the spirit, you're really feeling the non-binary neutrinos.
I got hit by a few too many neutrinos and this happened. I don't know.
This happened. Snart recap.
Snart recap. What did you learn today, James?
Well, today I learned that there's an ultramassive black hole that is acting as a telescope to give us more information about our neighboring galaxies.
Give me more. Give me more.
Give me more. What did you learn today?
Today I learned that the whole reason that our universe exists might be because neutrinos are trans.
Yes! Thank you.
And that is a massive swear. Happy
Yes.
International Trans Day of Visibility.
Exactly.
I'm so glad that we are able to be seen.
Finally, because we have that new detector in the Large Hadron Collider.
Yes! Thanks for watching.
Thanks for being with us on Snart Club, and we'll see you very soon.
Say hi to the neutrinos passing through you right now.